Hey you guys, and welcome to RuiRaptor YouTube channel. Have you heard about the new BLUER Plus from TwoTrees? So, if you want to know more, stay tuned. Hi guys, I'm Sandra, welcome back. But before we start, don't forget to hit like in this video and subscribe our channel. Also, if you want to help us make more cool videos, go ahead and join our Patreon page. So, today we will unbox, assemble and review the new TwoTrees BLUER Plus. This machine has a printing volume of 300 by 300 by 400 millimeters. And some of the announced features are TMC 2209 drivers, dual layer cooling fans, BL touch leveling sensor, 0.9 degrees stepper motors, easy access to the main board, magnetic steel sheet print surface, and automatic adjustment of the Z-axis wheels. Rui will explain you everything in detail, so let's start and unbox the printer.
Hey you guys, this is Rui. Right at the top, we have this gift. It's a mini wallet with the shape of the TwoTrees BLUER whale. Sandra agrees with me when I say that this is a very cute gift, and if you have girls, they will like it too. Next, we have the user manual. Some tools and parts, the USB cable, one piece of the spool holder, at the side we have a small spool of blue filament, here we have the second piece of the spool holder, this is the print head that we need to install later on, and the top half of the printer. Be very careful when handling this top half, because the Eccentric can easily slide out from the long vertical profiles. Next, we have the print surface. One leveling knob that got loose during transportation, the power cord, the cables that we need to connect later on, one more leveling knob, and finally the base of the printer. Here we have the top half. The print head comes equipped with a couple of layer cooling fans, one on each side. At the back, we can see the BL touch sensor and the hot end. This one has a volcano type hot end with the silicone sock on it. On the X-axis, we have a belt tensioner, and on the Z-axis wheels, we can see that there are no eccentric nuts to adjust the wheel's grip. Instead, the manufacturer implemented a system with springs that will adjust the grip automatically. At the back, we can see the translucent BMG clone extruder and the filament runout sensor. And at the top, we have the belt connecting the two lead screws to keep them in sync. and the bearings securing the lead screws. To connect everything from the base to the top half, we have these 3 cables. 2 of them are Cat7 Ethernet cables, which are normally used for data transfer. Inside the bag with tools, we have a memory card, Allen keys, wrench, and a small flat screwdriver, a PTFE tube, a memory card reader, some screws, a cutter, and some zip ties. The spool holder on this machine is very simple. We have the plastic shaft and a metal plate, secured by a couple of screws. The user manual looks very detailed and with lots of information, such as some assembly tips, error message and their meaning, troubleshooting problems, and also details on the main board and driver VREF adjustment. The print surface is a magnetic steel sheet with PEI surface on top. The magnetic base needs to be glued on the heat bed. And this is the base of the printer. At the front, we have the Y-axis belt tensioner and the 4.3-inch touch display. At the right side, we have a cutout for venting with the shape of the TwoTrees letters. Also at the side, we have the main input voltage connector and the on and off switch. At the back, we have a small fan and the cable that connects to the heat bed. At the left side, we have the memory card slot, the USB connector, and a sticker with some machine specs. To access the main board, this machine has a small panel at the top left side. The board is an MKS Robin Nano version 1.2, equipped with 32-bit microcontroller and 4 replaceable TMC 2209 drivers. To access the power supply and the rest of the components, we need to remove the bottom cover. The power supply is a 24 volts and 15 amps model and has the input voltage selector at the side. Next to it, we have the display and a small fan sending air to cool down the drivers on the board. Okay, and these are all the parts that came inside the package. To assemble the printer is very easy. We need to locate the openings where the vertical profiles will be placed and take the 4 long screws. The top half must be placed carefully while both lead screws are inserted in the couplings during the process. Next, the screws must be inserted and tightened from the bottom side. Then, the top screws on both couplings need to be tightened as well. Before installing the print head, we recommend to raise the X gantry a little bit by rotating the couplings. Use the 2 screws that are already on the carriage. Next is the spool holder. Start by securing the plastic piece to the metal plate. And then install the spool holder at the top of the printer using the nuts inside the top horizontal profile. Next, insert one end of the PTFE tube in the extruder. Check the length of the tube and also the other end of the tube. It must have a clean and straight cut to prevent issues with the hot end later on. Insert the tube all the way in the hot end. It must be inserted around 48 mm in. Confirm that the PTFE tube has the correct length and does not get bent when moving the x-axis all the way. Next, take the 3 cables and connect them at the back left side of the printer. The connector at the bottom right connects to the connector at the top right. Then, the middle bottom one connects to the middle top one. And the left bottom one connects to the left top one. Now, all it's left to do is to glue the magnetic base on the heat bed. Place the magnetic base carefully, making sure there will be no air bubbles between the magnetic base and the aluminum plate. Also, don't forget to remove the plastic protection on the print surface. The magnetic strength looks pretty good, and it's capable to hold the plate even on the corners. And the assembly is now complete. This is how the BLUER Plus looks like. Before running the first print, you need to make some adjustments. The first one is the leveling of the X gantry. You need to have the same height at the right and at the left. If you don't, you need to loosen one of the top idlers and rotate the coupling on the side you need to adjust to level it. Next is the wheel's grip. For the x-axis, the lower wheel has an eccentric nut that needs to be turned to adjust the wheel's grip. A grip too loose will make the carriage wobble, and too tight will make the wheels deform, so make sure you get the correct grip. We made a video that explains this in more detail, so don't forget to check the video description for the link. For the y-axis, the wheels at the right side also have eccentric nuts and need to be adjusted. For the Z, there are no eccentric nuts since this printer has the auto adjustment system that we mentioned in the beginning. But check the wheels that are on the other side because in our case, some were spinning freely, and we had to loosen the carriage and adjust it to get all 3 wheels running correctly on the profile. As for the X and Y axis belts, you need to check the tension and adjust if needed. Now, we can connect the power cord and turn on the printer. The menus are simple but also somewhat limited. In Tools, we have the preheat button where we can heat up the nozzle and heat bed. In Extrusion, we can push and pull filament. In Move, we can move each axis. In Home, we can home each axis or all axes at once, and also turn the stepper motors off. In Auto Level, we can run the leveling sequence, but we will cover that in a minute. In Filament, we can load and unload filament. In More, we have a button to calibrate the PID. This is very handy and will allow the calibration of the PID without the need of a computer connected to the printer. In Settings, we have a Wi-Fi button, but the Wi-Fi module is not included on the board. In Fan, we can control the layer cooling fan. In About, we can see the board and firmware version. The Continue button is for resuming prints. We also have one more button here to disable the stepper motors and a button to change the language of the menus. There are no menus to check and change settings such as steps per millimeter, acceleration, jerk, or velocity. If you want to change one of these settings, you need to edit a config test file and insert it in the memory card to upload to the board. The hot end and heat bed temperatures are also not available on the main screen. If we want to check the nozzle and bed temperatures, we need to go to the preheat menu, for example, to check them. During the first home sequence, we had an issue with the X-axis. This axis was failing the home sequence because the zip ties that secured the belt were hitting the blue metal cover. We had to remove these zip ties and install new ones with a different orientation to avoid this from happening again. Once that was done, the homing sequence ran without any issues. Although the printer has auto level sensor, we still need to level the bed. So, the best way to do this is to lower the Z manually until the nozzle almost touches the bed, and with a 0.1 mm thick piece of paper, we adjust the 4 knobs until we feel the nozzle touch the paper. Next, we need to run the auto level sequence and adjust the sensor Z offset. The machine will probe the bed in a 3x3 matrix, and at the end will stop at the center of the bed. To adjust the Z offset, we use the same piece of paper and raise or lower the Z using the buttons on the display. When done, we hit Finish and the Z offset is saved. We are now ready to load the memory card with some test G-codes and run some prints. Normally on printers with auto level sensor, most of us likes to add the G29 command in the startup G-code sequence in the slicer so it can run the leveling sequence every time at the start of the print. But on this machine we cannot do that. If we add the G29 command, the machine will run the leveling sequence by probing the bed and start the print, but the screen will stop at the Z offset menu. If we hit Finish, the Z will lower a few millimeters while continuing printing and this way damaging the print surface. The display will also not return to the printing menu, so the only way to stop the machine is to switch the power off. So, if you want to level the bed before each print, don't add the G29 command, and instead use the menu to run the leveling sequence. We also noticed that the bed cable was rubbing the back of the Y-axis during printing. The heat bed includes a strain relief, but the cable is too soft and easily curves down, so a modification or add-on must be done here to prevent this. In the memory card, we have a couple of already sliced models that we can use and print. The demo files from TwoTrees are displayed with a preview on this screen. This is possible if using a slicer that is compatible with File Preview. For printing tests, we printed one of the already sliced models that came in the memory card. We printed our traditional print test, the Benchy. We also printed a figure with our own profile. And finally a vase printed in vase mode. Although this printer is equipped with TMC's 2209 drivers, it does not run as silent as we would like. For slow speeds, the axes move silent, but with normal or faster speeds, the axes become audible. Also, some of the cooling fans inside the base are a bit noisy. The markings on this model were caused by the supports, but other than that and a bit of ghosting, it ended up okay. The print quality is not bad, but we see a bit of ghosting on the prints. We believe it could be improved if the tall vertical structure was secured with some extra brackets. This BMG clone extruder works okay. Just make sure to check and adjust the extruder grip before printing. As you can see, the printer was able to reproduce perfectly the small details on the surface of the print. At the beginning, we had some issues with stringing while dialing in our slicer profile. On this printer, we ended up on using a much lower nozzle temperature when compared with other printers and using the same filament. The surface of the vase turned out smooth as we used a slower printing speed. All our test prints were made with PLA filament. The magnetic print surface works very good. The filament sticks extremely well on the PEI surface, and thanks to the flexible magnetic sheet, it's also easy to remove. And that's it, you guys. Hope you liked the video and give it a thumbs up. Also, feel free to leave your comments down below. We will see you guys next time. Bye!